Hi, welcome to my lesson video on direct and inverse variation. Now let's get started. Now for direct variation, let's look at this key concept. Y varies directly as x if there is a non-zero constant that we're going to call k, such that y equals k times x. K is called the constant of variation. Now to help us understand this, we're going to solve this equation of y equals k times x. We're going to solve it for k. So we start out with y equals k times x. And what would you do if you want to solve for k? Well, you would need to divide each side of the equation by x. And in doing so, our x's cancel out and we are left with k equals y divided by x. Now sometimes I understand things better if I go ahead and I actually plug in a number for the variable. So let's plug in the number 10 for k. So we're going to say, instead of k equals, we're going to say 10 equals. Well, what are some fractions that we can use to represent 10? Couldn't we use 10 divided by 1? That equals 10. So do you see? The 10 is the k value, and this 10 that's the numerator is the y value, and this 1 is the x value. So we're saying k is equal to y divided by x, or 10 is equal to 10 divided by 1. Now, what are some other numbers that we can divide to equal 10? Well, we can say 20 divided by 2, 30 divided by 3, 40 divided by 4, and I think you're getting the picture, okay? Now, when we do this, let's look at this next question here. We're going to look right here. If y increases, what is happening to x? Now remember, all of our numerators are the y values. So as our y increases, what is happening to x? Well, our x is increasing also. So as y increases, our x also increases. So now let's look at the next question. If y decreases, what happens to x? Well, if we were to have started at 40 divided by 4, and then y decreased to 30, we're dividing by 3, then it would decrease to 20 divided by 2. So what's happening to our x value? Well, it's also decreasing, okay? So as y decreases, our x also decreases. Now this is why we call this direct variation, and right here we would say that it varies directly, and that's because as y increases, x also increases. So the variation, there is a direct relationship here. Now let's look at an example. If y varies directly as x, and y equals negative 15 when x equals 5, then find y when x equals 3. Now we would set this up as y over x equals y over x. So let's start plugging in our numbers. Our first y is negative 15. And so y is negative 15 when x is 5. We will set that equal to, and it says find y, so we don't know y, we'll put it in the numerator there, when x equals 3. Now, I don't know if you remember about how to solve for a variable when you have two ratios or fractions equal to each other. We can actually cross multiply here. That's a method we can use. And in doing so, I would say that 5 times y is 5y. And then I would say that negative 15 times 3 is negative 45. And I would divide both sides by 5 so that I could isolate y. And when I do so, I get that y would equal -9. And so if we were to plug -9 in right here, we could put these easily, well, let's just do the division. -15 divided by 5 is -3. And then we have, -9 divided by 3 is also -3. So this would be our constant of variation. K would be our constant, -3 would be our constant of variation. Now let's look at inverse variation. Now the key concept for inverse variation is y varies inversely as x if there is a non-zero constant, k, such that y equals k divided by x, and x and y cannot be 0. Now, I know this might sound a little confusing, but we're just saying y still has this relationship with x. It varies, but instead of varying directly, it varies inversely. And if direct variation means as y increases, x increases, well, what do you think that means? And I know I'm skipping down already to right here, but with inverse variation, remember, it's the opposite. So instead of x increasing as y increases, what's going to happen to x as y increases? Well, it would decrease, okay? So the x would decrease as the y increases. Okay? So now let's go ahead and talk about, well, what if the y decreases? What's going to happen to the x? Well, the x would increase. Okay? And so that's what it means to vary inversely. Now, so to help us see this, why don't we go back up here and solve for k? I'm going to take the y equals k divided by x, and we're going to solve for k. So we start out with y equals k divided by x. Now, if I want to isolate k, what do I have to do to x? Well, in this case, since k is being divided by x, I'm going to have to multiply each side by x. And if I do that, my x's cancel out on the right side. And so that means k will equal y times x. And yes, you could say x times y. Now again, it usually helps me to get a better picture of this or really understand this better if I actually use a real number instead of just k, y, and x. So let's just say that k equals 100, okay? Now remember, if k equals 100, so this would be our 100, we've got to find two numbers that would equal 100. And those two numbers would be the y and the x. So let's start out with 100 times 1. Okay? Well, we know that 100 times 1 is 100. Well, now let's look at 50 times 2. Okay? What about 25 times 4? And we could do 20 times 5. And let's go ahead and do 10 times 10. Okay? Okay, now we can go back and let's look at what happens to our x values as our y values increase. So, let's start out with if our y decreases, okay? So our first y is 100 and our x value is 1. Well, when I decrease my y value to 50, what has actually happened to my x value? It has increased, see? When I decrease my y value to 25, again, my x value increases, okay? Now let's go the opposite way. If I start out with a y value of 10 and I increase it to 20, what actually happens to my x value? It decreases. It does the opposite. So that's why we would call this inverse variation versus direct variation. Now let's do an example. If r varies inversely as t, and r equals -6 when t equals 2, then find r when t equals -4. Now, when we're setting up this equation, we are going to set this up as y times x equals y times x. Okay, and I'll write that right here. And yes, you could put xy equals xy. Oh, and in this example, the y is the r and the t is the x. Okay, so we would have rt equals rt. So our r for our first r is -6 and our t is 2. And then it says to find r, so we don't know what that is when the t is -4. So now go on the left side of the equation. -6 times 2 is -12. So basically we have -12 equals -4r. And so to isolate r, we would need to divide both sides by -4. And if we do that, -12 divided by -4, I guess I can show that here, would be +3. So now in looking at this example, can you tell me what my constant of variation is? The k value. Now remember, with inverse variation, the k equals y times x. So if you look on the left side of this equation, we have -6 times 2, which is -12. And if we were to plug in the 3 for the r on the right side of the equation, we have 3 times -4, which is -12. So in this example, our constant of variation would be -12. Now I hope this video has helped you understand a little bit more about direct and inverse variation, and I look forward to working with you again. Bye-bye.